Here are the notes for section 4.4, continued from class. Okay, we're going to look at the power property of logarithms. Alright, so if we have a power or an exponent with our number in our logarithm, so as we see here 10 cubed, so this is like saying 10 times 10 times 10. And remember with the properties that we did in class today, multiplying your numbers in here can be written as addition. So we have 3 of the same thing. We can do 3 times log 10. So basically the property is, if you see, the 3 goes from the exponent out front. Okay, so let's just do a couple examples. So let's say we have log base 4 of x squared. The way that we would simplify this, the 2 in the exponent can be moved out front. So this is the same as 2 log base 4 of x. Okay, our next example, let's say we have log x to the 10th, so our common logarithm. And again, same thing, the exponent can be moved out front. Alright, so just a couple basic examples of our power property. Okay, so example 1, express as a product, simplify if possible. So express as a product means use our power rule. Alright, so for A, let's move this 6 out front. And then what we want to do is look at just the log and see if we can simplify this. Okay, which we can. Alright, so this is saying 2 to the what is 32. Okay, and that is 2 to the 5th. Alright, please feel free to use your calculators for those. So we're doing 6 times 5, which will give us 30. Alright, for the next one, first thing we're going to move the 20 out front. So 20 log base 8 of 4. And again, we want to look at this and see if we can simplify it. Okay, this one's a little bit harder. So 8 to the what equals 4. Alright, so if we look at this, the number got smaller, so this would be like a decay problem. Alright, so we know that the exponent here is going to be less than 1. Alright, so let's try a couple. Let's say 8 to the half. Alright, 8 to the 1/2, put that in our calculators, is about 2.8. Let's see, so the fraction has to be a little bit bigger to get to 4. So let's say 8 to the, let's see, a fraction bigger than 1/2. How about 2/3? Okay, 8 to the 2/3, and that is 4. Okay, so a little bit harder problem to figure out this. This is really 20 times 2/3, which would be 40/3. Okay, and again, I wouldn't expect you to figure out this part here without your calculator. Okay, so a little guess and check here. Okay, next, same kind of problem. Move the 4 out front. Okay, so now we want to look at the log problem and see if we can simplify this. Remember, it has an invisible base of 10. So you're thinking 10 to the what is 10? And of course it's 1. So this is really 4 times 1, which is 4. Alright, more of the same over here. Move that 2 out front. 2 log base 5 of 25. Okay, so let's see if we can simplify. 5 to the what is 25. Alright, not that bad. 5, what is that, squared is 25. Okay, so this is 2 times 2, which is 4. Alright, next one, a little bit harder. Move the 5 out front. Alright, so what I want you to do, simplify the log here. Okay, I want you to pause the video, simplify the log on your own, and then hit play again to check your answer. Okay, so what we're thinking is 2 to the what is 1/2. Alright, since we have our fraction, we know the question mark is going to be negative. Alright, and the answer is -1. Alright, because 2 to the -1 is 1/2. So this is like 5 times -1, which is -5. Alright, next property we have is the inverse property. Alright, since exponential and logarithm operations undo each other, they're inverses. Okay, so we see if we have log base b of b to the x, we know that's going to equal x. Also, if we have it as an exponent, b to the log base b of x, so that whole thing, that log is in the exponent, is going to equal x. Alright, so for example over here, if we have log base 10 of 10 to the 7th, let me just write that out again. Okay, remember if you're simplifying this, you're thinking 10 to the what is going to give me 10 to the 7th. Well, the what has to be a 7, right? Okay, and same thing with our exponent. If we were going to rewrite this in log form, we would get 2. Okay, so let's just do that one real quick. So we have 10 to the log base 10 of 2. Alright, so this would be, let's just say it equals y for now. So this would be log base 10, right, because 10 is the base here, of y equals log base 10 of 2. Alright, so this became the equal to here. Okay, so if we match them up, log base 10 has to equal 2. Alright, so that's why we got the 2 here. Alright, let's do a few more examples of those. Alright, simplify each expression. Alright, so if we're going to simplify this, we're thinking 3 to the what equals 3 to the 11th. So the answer has to be 11. Alright, a little more work with this one. If we were just going to solve this, we would say 3 to the what equals 81. Alright, in our calculator, a couple tries, we should get 4. Okay, now this goes along with these expressions because 81 is 3 to the 4th, so our answer is 4. Okay, and our next one here in log form. Alright, so let's say this equals, it can equal any letter. Let's pick G. G is a good letter. So if we're going to write this in log form, log base 5 of G equals the exponent, log base 5 of 10. Okay, so if we match these up, we're going to get 10. G has to equal 10. Okay, so we can see the shortcut in each of those. Alright, equals 10, right? They're inverses, so they undo each other. Equals 4, equals 11. Okay. For these next two here, I'd like you guys to pause the video, take a minute, and solve each one, and then play and see if you got your answers correct. Okay, so this one is a base of 10 that's invisible, we don't have to write it. So the inverses undo each other, and we get 0.9. For part B, again, the log and the exponent are inverses, so this will be 8x. Alright, a little trickier there with B because we have an x in our answer, but it's the same idea.